Okay, we still have a couple of minutes before the class starts. Okay, let's get started. I'm just setting up some things. This is not the interface. Okay. Okay, so I want to, spend 5 minutes just talking about some logistics. It's important because that's one of the logistical items is actually the project, and I know I've spent like 5-10 minutes at least 15 minutes last time. But I do want to kind of emphasize that most of you have formed groups, but the students who did not form groups, I sent them an email. I don't know if, I think here probably everybody has formed a group. So you need to enter your names, which you probably have already done. But if you already chosen a project, like which tool you're going to kind of familiarize yourself with, then it's good to enter that name also, so other students don't take the same tool. And if they take the same tool, then they should change. Okay. Ideally. So we want to avoid those conflicts. So it's good to enter your tool name into that list. There's a column for tool name and also a link if it's an open source tool. Or even if it's not an open source tool, you can just link it. Okay. So again, I don't want you to be pressured about the project. It's mostly an exploration. I mentioned it several times over the past 4 meetings. But basically pick a tool that you think is interesting and you might think that it might be useful for your own career, or it's something that you're interested in deep learning or interested in large language models, you're interested in something else. Then there are tools which are about them. Okay, if you're interested in image only image recognition and image related problems, then are tools related to that. If you're only interested in web like web frameworks, like there are tools related to that. So pick whatever is of interest to you and do a good job of like understanding it, playing with its use cases and getting a sense of what the tool is about and where you could use it. In your report, obviously, it will be more detailed, but in the presentation, you're basically explaining what you tried, what was interesting and what was not interesting about the tools. Okay. So if you still have concerns about the project, talk to me during the break or after after I finish the lecture part, so that it's more clear like what you want to do, because it is 90% of the grade. So hopefully you are in the right direction and not like completely orthogonal to where we are hoping to be in terms of the project and presentation. Okay. You just scroll down a little bit just to mention where we are. We are actually lecture number 5. We are going a little bit slower. So last time we were supposed to cover model versioning and data versioning, but it's okay. So we'll look at those versioning ideas today, in addition to the Git related versioning that we were seeing towards the end of last lecture. Basically about there are 2 weeks from today to submit your report. I know it's a little bit early because there are 2 sessions given the number of students, which is about 15 groups or something. So there's a lot of groups. And so one session is not enough to kind of talk about a tool and really absorb what it is about. And so in 2 weeks, you should submit your project final report. And so if you are lost, again, look at the project guideline here. There's a project notebook. And if that is also not clear, you can raise an issue, which I'll show today, but you can also email me and we can clarify that, okay? The earlier you figure this out, the better, so that it's a smooth ending to the course. You investigate a tool and discussing it with your fellow students, okay? So what I'll do is on that day or a couple of days before, I'll also set up a box upload folder where you can submit your slides with some instructions. I'll give an instruction next time, but you can upload your slides so that there's no need to switch devices and stuff. So that information I'll send across via an announcement. Okay. So yeah, hopefully this project component is, although it's a big part of the grade, it should not be a stressful activity. It's something. So I'm trying to ensure that it's not the case. So definitely reach out if you or anybody in the online are concerned about it. Okay. Okay, so what we want to do today is get back to our bucket of things that we're looking at. Do I need to sign in? Don't need to sign in. Let's see if I can just see this. Okay. Yeah, so look at the second bucket of things that we started last time, which is in general about model management. It's not just specifically model, but it's anything to do with ML, management of artifacts that you create while you're processing data, while you're training models, artifacts that you create sometimes when you're doing inference, setting up inference, which is what the first part was. Like first part was like, okay, let's say we already have a model. How do we expose it to users? And I was just reading up some news articles and ChatGPT, right? So some analyst, okay, this is external information. Some analyst was projecting that they are spending about $1 million a day This is back in 2023. Okay, so $1 million a day for the infrastructure for this 100 million plus users to actually make queries. Because at the end of the day, it's an inference endpoint. You send a string and you get back a bunch of strings, sentences as a response, right? So they're spending $1 million a day. Okay, that's $4 million a year, which is a lot of money, for their users. So that's really the extreme example of a successful deployment, or at least things related to the first bucket. Okay, but behind the scenes, there's so many other prep things to do to actually get to that stage where you can deploy a stable, well-running model, right? So what is that behind the scenes stuff? One of them is actually management of different artifacts, and here I'm just calling it model management. So there are three parts that I'm going to look into related to management. There are actually many other things, but three parts that I have characterized are recurring jobs, basically scheduling things to happen again and again and again, hopefully periodically. Okay. And the second bucket is versioning. And this is what we had started with. We were talking about code versioning, and then we'll hopefully get into other versioning aspects. And the third bucket is testing, which the more emphasis is on the statistical testing aspect rather than the software testing aspect. Okay, so we'll briefly comment on both. At least we need to be aware of like what type of testing you want to do at different situations. So with that background, it looks like there's a question. Okay, so the question is about project. So let me just clarify that. So there's a upload link on Blackboard for the project. Yes, that link is for the project report. The box upload is for your slides, so that there's no friction between switching between groups when you present in the class. Okay, so the second upload is really not. Anyway, the presentations are not graded. It's still, you need to do a good job of explaining what you did. But the second link is just it's just to ease the friction of switching between presentation slides. Okay, so the box is just a informal thing. I'll do an announcement. I'll send an announcement email in the next week or so. It's not urgent, but the main thing is obviously your Blackboard upload. There is obviously a time limit, so try to upload hopefully before time, and that's the link for your project submission. Okay. Anyway, so that was just a tangent. Let's come back to versioning. Last time we had started code versioning, and the reason why I picked that order is because code versioning is where you would spend majority of your time. Okay, so you as in like whether it's a data scientist, a business analyst these days, previously they would predominantly be dependent on tools like Power BI or Tableau and whatnot. But there are actually other tools also which are which are coming out, but increasingly they might have to maybe run SQL queries. Okay, SQL is also a code. At the end of the day, the query is a bunch of strings with some instructions on select these columns, join with that, and so on. So there is some level of versioning that is kind of needed. And for example, tools like how many of you have heard of Snowflake? It's a big market leader, kind of captures that part of these data market. And so they have worksheets which are just SQL. You can write SQL queries in basically text files on their online editor, and they do versioning behind the scenes for you. And that versioning is very similar to how you would have Microsoft Word do the versioning for you. Like if you write something, they take snapshots, they autosave. Autosave feature is something that some providers already provide. But what we're talking about is a little bit related to that, but it's just a little bit manual, but just gives you a sense of why versioning and version control is useful for code. Okay, and code is just think of it as a language, right? Language to instruct computers to do something. So last time we started with this, we talked briefly about Git, and we'll quickly recap that. We got stuck at some stage. It's not stuck, but we stopped at some stage where I was trying to show merge, but I didn't have permissions. I'll just show the merge today. So code versioning is one, and then that's the closest. That's the majority of the time. I would say, irrespective of what your profession is, probably that's where you would spend time. If you're obviously into data engineering and ML engineering, which is a broad area, it doesn't have to be engineers, but so you might have to version the models of the data scientists and the teams who are producing models. You might have to version control them. Okay, and finally, you might have to version control data. There are multiple ways to version control data. Many approaches. We'll just see one example, which actually is very similar to Git's flow of doing things. That's why we'll see that example, but that's not the only predominant way. Okay, it just gives you a sense of, okay, we need to we need to keep snapshots of things, not just because we want to have a sense of how did we evolve over time as the project evolves, as the models evolve, as the data evolves, but also in case you have to roll back. That's a very obvious use case. But just to ensure that you're not you have like ways to kind of go back and create another feature, branching and stuff like that. You can do those things. Okay. And versions are useful because everybody can start from the same snapshot, and maybe they'll have their own executions and idiosyncrasies in their own development environment or production environment and so on. Okay, so those are the three things. We'll immediately not talk about the other two buckets, which is scheduling and testing. But when we get there, we'll briefly discuss that. And there are a couple of slides here. But as I said, much of the course is actually reliant on the documentation for each of the tools, and which is what also you should rely on for your project. So we'll kind of rely on the documentation for the tools that we'll see today. So we'll continue with Git. GitHub has a bunch of really good, helpful documentation, but for Git, I'm not really showing documentation here. So let's get back to, so for the next few minutes, what I'm going to do is finish up Git, or at least a recap and the couple of operations in Git, and then we'll talk about model versioning and data versioning. Okay, that's the immediate near-term goal. I think for Git, I also have a slide, which I think it's towards the end, but let me just show that. Yeah. I should move it actually up, but so last time, this is what we were doing towards the second half of last lecture. If you look at the recording, this is what we started. We were just kind of motivating what is Git and what is GitHub and Bitbucket and GitLab and other vendors who allow for this version control and many other set of features. Okay, GitHub Copilot, for example, is a feature by the same company, which helps developers. There is other features, collaboration features that I briefly mentioned last time, where multiple people can comment, discuss, and work together. So that is already enabled by Git in terms of the bare bones Git program software, which is itself, it's just a binary. You can install it in any operating system and work. But the collaboration feature without this vendors would be based on email, sending each other and so on, of the differences in code. Instead, these vendors provide some extra bells and whistles. So last time we saw how to make a commit and how to make a branch. Okay, so let me just mention the verbs. Commit, pull, and push are about snapshotting something, pushing that snapshot to some remote location. In this case, typically it's going to be the vendor's location so that other people can copy it from there. Like you'll be pushing something to GitHub, pulling something from GitHub in this example. And commits, you're going to make it either any location. You can actually make commits directly on GitHub through editor that they provide in the browser, or you can make commits in through VS Code, like in the command section, right? In the terminal section at the bottom. Okay, so those were the things that we saw, and let me just open up that. So this was okay, actually. So last time, what did we do is we created an example through Copilot, which is just a web framework. So Copilot is just an extension. Remember, we installed it like a couple of lectures ago, and we asked it, okay, can you give us a minimum working example for something equivalent to Flask? Okay, and we got an example, which is actually this, which looks exactly like Flask, but doesn't have a main function. And last time we couldn't execute it, but it turns out there's a different way to execute it because it's based on some asynchronous processing principles and not the typical way Flask works. And the way you'd execute it is to run this command here. Okay, so actually let me copy that and look at status. Okay, so this is another command, helper command, just to see what is the status of my code base. Okay, this is our MLOps code examples code base, in which I had created this subfolder called Copilot example, just one extra folder, within which there's one py file and a requirements file. Okay, this is what we did last time. And in fact, we also made a commit. We made a commit step, okay, last time. So if you look at Git, let me just do git log is again a local way to see what commits are there, what snapshots have we done so far. You can see that there was a snapshot exactly during the last lecture, and it said fast API is not working. Okay, it actually works, but we didn't test it correctly, and so we said this is the commit we made last time. Okay, just to kind of enhance it, let's actually make another commit. Let's say. Okay, using let's call it this string in the command line. Okay. So we added an extra sentence. So again, what we'll see is obviously, I think you might have observed pattern. Now you'll see that something got modified. At least it'll say that, hey, you've changed some files here compared to the commit and compared to actually the remote location as well. Remote location probably just has without this extra line. Okay, we can just see that also when we go back to GitHub. For us, the remote location is just GitHub, and then we have one working version in our laptop. Okay, so let's actually add that file. So we know that. So the way to make a commit is you add and then call the commit command with a message. Okay, so you add that file. So add means like, okay, I'm ready to kind of make a snapshot with the updates in this file. Okay, now you can add if you have more than 5 files or something. You can always add each one of them. You can also add easily by just add space dot. Okay, there are multiple ways to add multiple files, but let's not worry about it. This is a way to add something to be ready to be committed. Then you just say git commit minus message. Minus m means message. This is a command line argument. You might have seen like many command line arguments, the minus something equal to something. Right, so message being fast API command line, command line statement added. Okay. So that's the commit. So this is now a local snapshot. If you look at git log again, you'll see one extra thing saying, okay, this is a snapshot. There's a lot of numbers and so on. That's just for computers to process. For us, it's just a snapshot. Okay. In fact, you can actually if you look at the third symbol here, it's by default, you will see that in VS Code. So in the third symbol, you can actually see what's the, actually you can see the, okay, it's not showing the tree. It's only showing the changes. And it's actually letting you commit, but let me not fiddle with this at this point. So what I want to do is now we have a local commit and you can actually push it. Let's push it to GitHub. Okay, so that's just simple git push. Okay, we did this last time, so I'm just kind of repeating what we did last time. Okay? So we saw the commit command, we saw the push command, and obviously if you do git pull, there's nothing going to change because our snapshot or whatever our sequence of snapshots were the latest. Compared to the remote location. So in the sense that both are now currently the same because we just pushed something. Okay. So we looked at those 3 commands. And last time, we also looked at branching. Okay. So that's again, I'm using a helper command called status to show that we're actually in the branch called origin/copilot. Okay. Actually, yeah, copilot -example. So the remote location is called origin / copilot -example. Okay, this is just some default name. Don't worry about the origin part. It's just something which says, okay, where is the remote location? Kind of some sort of identifier. But the branch name is called copilot example, and this is what we created last time. So the way you create it is git branch. Okay, git checkout minus branch, and you can give a branch name. So the current snapshot will have now will go into a new branch. So next time, so if you keep making snapshots, that'll be under this new name. Okay. So you can say new branch. Let's give some branch name. So now we are in a different branch. Okay. So if you look at git branch, you'll see that now there was the original branch that was the default branch before we started all this exercise of adding this new example. Last week, we started a new branch called copilot example. And just now I created another branch. from the Copilot example. So you can branch from a branch. I think last time somebody asked the question, so you can branch from a branch. But let's actually go back to the branch that we care about, which is Git. Yeah, so we just switch. So this is how you would switch. Like, let's say there are two very different files sets. Okay, in one branch there are like 10 extra files. In the other branch there are like completely different branches. You can just switch, and the files will get replaced. Okay, behind the scenes, because Git is taking care of, oh, if you're in this branch, what's the latest snapshot? Let me populate the current folder with those files. So you should not think of the current folder as some sort of sacred location where that's the master copy or anything like that. It's all in the snapshots. Okay, so you'll not really lose anything. And obviously, if there's a file which is not even being considered as part of the snapshotting process, like for example, if you look at Git status, there is a file, some notebook that I created some time ago. It's not part of the snapshotting process, so it won't get deleted just because you switch branch. Okay, so switching branches is for things which are being tracked; they'll get swapped out. Okay, and it's fine to be swapped out because they're actually if you just want to recall them or get them back, you can just switch back to whichever branch or whichever snapshot you're in. Okay, so this is the local thing. We did the branching. Now, last time we also once we did an update, we pushed it to the remote location. For Copilot branch, the first time you try to push it to the remote location, which is our GitHub, if there is no branch on that side, it will say, hey, there is no branch on that side for Copilot example. And last time we had to execute, it will just tell you, hey, execute this one-line command which says connect this branch to potentially a branch over there. Okay, so that I'm not going to show that because we already did that. But the end result of that is that if you go back here, so this is MLOps code examples repo, which is exactly like, for now, when you guys downloaded this, if you did git clone, you can now just git pull and you'll get these minor update of, okay, there's a line changed or a couple of lines changed or something. So right now, last week, since we pushed that branch, as in pushed it, it's also here. But the new branch that we just created, it's not here because it's just local to us. Okay. If I try to push it, it'll say that, okay, on GitHub, that branch doesn't exist, and it'll create something for us. But let's ignore that. So this is the branch. And now the last process that we're going to just to wrap this up, at least wrap that, few key workflows related to Git is the process of merging. Okay. In Word document, when you do collaborative editing, there's really, whoever is the latest in editing the sentence or the word, they get to be, it automatically kind of edits, gets to that stage. Okay. Whereas here, we need to explicitly do a merge operation. If you have branched out and you built a feature, in this case, we created a fast API example. We're happy with it. Now we want to kind of put it back as a key result in our original branch, which is like, let's say, the canonical branch here. Then we need to do what is a process called merging. Okay, we need to do a process called merging. For the vendor GitHub, they call it pull request. In other vendors, they would have different names. Okay, for Bitbucket, for example, they just call it merge request. But anyway, the different verbs, but they basically mean the same thing. Now you're trying to bring two branches together so that the feature branch that you worked on, you're fairly happy with it. You just want the final result, in some way, kind of be reflected in the original branch. Okay. So the way to do it, I think last time we did it, actually, and I did not have the permissions, but this time I do have permissions. I just gave myself as this user has a permission to edit my username / MLOps code examples for repository. So let's create a new pull request. It's very simple. So let me. Okay, so the way you do the PR is you choose what you want to merge into and what you merge from. So let's say we merge from Copilot example. And yeah, so there are two commits from last time and this time, which create that example. And we felt that it was not working, but now we added that statement so that somebody can read it and say, actually, yeah, it's working. By the way, it does work if you run it. I didn't show the fast API, in the browser, but if I click on a link, it would work. Yeah, so this is the new files that were created, the example and the requirements text, with the extra sentence also, which was in the second commit, which we pushed. Okay. Yeah, and then we can just create a pull request. Um, and you can add description and so on. Typically, what you do is actually add reviewers. So if there are other people in the team or in the organization that want to check what you're committing, then you would add them. So these are extra features that this vendor and other vendors also provide. Okay. Yeah, and then you can just create a pull request, or you can create a draft version. It depends on what you're doing. Yeah, and you can actually set up rules and policies, and this is like now getting into more details, but such that developers cannot arbitrarily merge things into the, let's say, a canonical branch, like the master or the main branch, so that you can have some security and policies in place and so on. Okay. So yeah, so typically, if we did not change things, which other people also changed. Okay, so let's say somebody else also created a fast API example with exact name, the exact almost similar code but slightly different. Then there's going to be what is called a merge conflict, because when we branched, there was no such fast API example in the canonical branch. But after that, maybe somebody else did that fast API example and already merged into the master. Now, when we are trying to merge, there could be name collisions, or whatever the expressions, the statement collisions in the files and so on. Okay? Obviously, in our case, there was nobody else which did that, so there is no collisions here. The collision resolution is actually, it's not automatic compared to like Google Docs and so on, in the sense that there are multiple ways to kind of resolve the collision. It's not complicated, but it does require a developer to kind of look at, okay, where is the collision happening and what's the right information to pick and choose, maybe, and so on. Okay, so that can be done. If there's a collision, it will tell you how to resolve that collision. Okay, and that's it. And you can merge and then just confirm merge. Okay, so what it does is the request, the merge request that was made, it's completed and it's closed. And so you go back to so there's some tab items which you did not see. They're actually, these are the features that we're talking about, vendor specific features. So in this case, this vendor has, lists what are some open pull requests. Like, let's say there are 10 developers, maybe they're all working on something for 2 weeks in like a typical sprint that you would see in development. Then there would be like 5 or 10 pull requests open. People would have reviewed them, other people's code. And then, at the end of those 2 weeks or 1 week, or whatever the process is, they would close them. Okay, so you can actually see what was closed also if you go to that tab. So that kind of is at least a minimal workflow to get a feel for branching and then merging. Okay. Obviously, once you actually work with multiple people, then you'll kind of see some pathways where there could be some collisions or some updating needed, git pull and push needed. If you're a single person, if you're a solo developer and you're just working with a remote location just to kind of snapshot your data and replicate it there, you'll probably not have issues. But it's good to have a copy of your code, not just in a development environment, but really think of the remote location as some sort of like a canonical location. Although Git is completely distributed, any location can be considered a principal location if you want. Okay. Any questions about this? Okay. So since we are on this tab, I want to briefly mention that this vendor provides a way to raise issues. So issues are, for example, let's go back to our code and let's go to that Copilot example. I mean, it's not really about Copilot, but let's go here. And let's say somebody did not understand this. Okay, you can go. So you can actually click on that line, basically on line 13, and you can say, okay, let's actually open a issue. Clarify. Sorry. Right. So anybody can, I mean, generally in your team, if it's a private repository in your organization, somebody would, do this if they want an out of pull request flow clarification. Okay. During the pull request, actually, the reviewers can comment very easily on the on the text that was changed, on the code that was changed. Okay, that would be within the pull request. People can add comments, which I did not show. But if you have outside the pull request and you have some comments, okay, I don't understand this part of the code, and it's influencing my work, like some model parameters or something, then you can always ask somebody, hey, can you can actually tag them and say, hey, can you explain this? Yeah, those are issues, and issues I generally think of them as issues with your training code, inference code, whatever it is. Okay, issues exactly mean bugs also. So it's just bugs that you face or you don't understand, or if it's failing, just say, hey, in this situation, it's not working. Please, look into it, right? We already looked at pull requests, and then we'll look at actions today, later on. Actually, when we talk about scheduling, we might look at actions. So this is related to automation. Okay, so when we get there, I'll talk about it. Okay, so I don't want to directly jump to that topic. Projects is exactly project management. It's basically like it's exactly like, I mean, wouldn't be exactly, but it has features similar to managing projects that you would see in tools like Jira and Asana and others. Wiki is just a place where you write text. It's like writing information about how to install, how to deal with things. We have seen something like this, I think, when we were running the OpenFace example, and the instructions of how to install on Mac or Windows and so on was in such a place. Okay. And then there are other tabs. So let's actually go back to our slides. So what did we do? We just did commit, branch, merge, pull, and push. Okay. There are quite a few verbs. In addition to that, you saw also the add verb and then the status verb and the log verb, but those are just helper, statements. But it's good to get familiar with it. And VS Code already has like that third source control. What is it called? Button here, and you can actually, I mean, it has debugging and many other things. Source control button has actually many choices that you can also make, but I'm not showing the details here. Okay, so we also saw pull requests. That's the fourth point here. Given this much information, I would encourage you to try out, let's say GitHub, or other ones also have similar features, GitLab and so on. You can actually create your own web pages where you can have a portfolio of your work if you want. If you have projects or something to demonstrate, you can actually create with your username.github.io or equivalent, or gitlab.io or something equivalent. So you could try that. So finally, we have already seen Copilot. Webhooks we will not see, but GitHub Actions, we'll just reserve it for a little bit later because we're going to talk about it. Any questions about this code version control, which is actually 95% of the time? If you're actually specialized to model version control and data version control, which is the next couple of topics, we'll look at that now. Okay, so let's actually then talk about model version control. So let's actually jump to a tool. Okay, so the tool is called MLflow. It's an open source tool by a company called Databricks, which, how many of you have done the big data course and worked with Spark before? Okay, so Databricks is a vendor. It's one of the biggest managed service provider for Spark and distributed data processing infrastructure. So they have, we are just going to look at their example way to model version controlling, but there are other vendors and other tools to do the exact same thing. Okay, so let's actually look at directly get to the docs of this thing of this tool. So model version control is exactly as the name says. I don't want to spend too much time on it in terms of what it means. It's basically just versioning your model. So every time you train, do you replace the previous model that you trained, or do you kind of store it somewhere so that you know what was the model that I trained last week, what are the performance numbers, what were the hyperparameters I used, maybe how much resources it consumed, all sorts of numbers related to it, including maybe confusion matrices and things like that, whatever plots you generated. All of that is saved in a nice way so that you can roll back and forth if you want to expose them to your users. Okay, so there's some connection to inference because inference needs some model, right? Starting point is a model, and your training whose ending point is a model. So somehow you want to kind of manage that ending point and starting point properly so that it's a smooth process. Okay, so rather than sending files and zip files and whatever pickle files back and forth. That's not the right way to do it. So that's the gap which these types of tools try to fill. Okay. So although MLflow, since its inception has evolved into doing other things, but we'll only focus on the model version controlling aspect of it. Okay. So yeah. So yeah. So it has. I will not try to kind of mention all these various characteristics that it has. We'll only focus on just tracking, which is model tracking. Okay, so we'll only focus on this. So what we want to do is when we actually do a training run, we somehow import this particular library. Okay, this is how the pattern would be. Generally, just like other things, we'll import this library, and somehow when we run our training run, we are able to kind of save this information about what the hyperparameters are, or what the loss values after every iteration or after every epoch. Through this library, we can save it on like a disk, a regular text file, or it could be in a remote location. So that's what this tool does. And you'll actually see that the user interface looks like this. But actually, let's actually do a quick start example. Yeah. So for that, there is a couple of notions to version controlling models. One is runs. Run is the actual, like if you train a couple of times, maybe the first time you trained, you did not set a variable correctly and it errored out. Okay. Second time you trained, you chose maybe suboptimal hyperparameters. That's all. Those things are called a run. The experiment is called experiment is just a model specification level grouping of these runs. Okay, so maybe you're trying out random forest instead of let's say a logistic regression model. Then anything and everything that you're gonna multiple times you want to train and figure out the best things to do for that family of models. That collection of runs would be called an experiment. Okay, so it's just a think of experiments as a grouping of runs, and runs are the exact execution of training of your models on some data. Okay, so generally, what is the way to do it, right? So the way to do it is just simply import that package, in this case, MLflow. And MLflow has ways behind the scenes to kind of integrate well with scikit-learn or PyTorch or there are many different modeling packages in Python, for example. So they have written these integrations so that they can track any type of model in terms of the loss values and parameters and so on. Okay, obviously, the way you generally do it is if you want to log a parameter, these are outside the model. If you want to log a parameter that you initialize in a script, so you know what the parameter is, you can just feed that in and call a statement like this. Okay, this is literally like print what is the parameter. Instead of print, you're calling mlflow.log parameter. Okay. Similarly, there's a slightly different thing called a metric. Metric is things which are evolved during the training. Right. So if your training has 10 epochs or 10 iterations, then at every end of the iteration, you may have a number that changes. And so log metric would be something that would capture that. It's a little bit different than a parameter, which would be static for that run. Okay. And also there's a thing called a log artifact, which will log like a confusion matrix plot, like a PNG file or some image file of your confusion matrix for your training run. They can be logged using log artifacts. Okay. So let's actually yeah, I mean, before we get into one minimal code example, I just wanted to show what is going on, right? In terms of blocks, we have our training set, like let's say scikit-learns, we import data, we call fit and transform, and then we can just do predict on, let's say, a test held out test data set or held out validation data set. That code is here. Okay, it's regular scikit-learn code. Then you have the tracking APIs. They're just calling it tracking APIs. Those print statements, which are not exactly print, but mlflow.log param and log metric. Those statements, they let you save that information in either a local file, like locally on your disk, wherever your directory is. They let you save that information either as a regular CSV file or as like if it's an image, obviously it's not going to be a CSV file, you can save those images. So that's the default way. That's the default thing that you can do. So as a developer, if you want to kind of do runs and you're not connected to like an actual explicit tracking server, then those things will be saved anyway. So there's not going to be any like strong dependence, and you need to have some tracking location where you send information about what parameters were and what the performance was. Okay. The second, I guess let's not worry about the second version. It's basically the differences in the database. The last version is what the typical use case would be in an organization where developers would be writing their code. They'll be running things. They could be writing codes on clusters or whatever, some dedicated GPU resource, for example. And then you would have those exactly the package installed, MLflow, log parameters, and so on. And then maybe there's another team which takes care of spinning up a tracking server where all this information is saved. Okay, so there could be 3 different data scientists trying out 3 different models for the same data, perhaps, and all that information is saved at the same tracking server, so that anybody else or even each one of them can look at that to see what is the situation with different types of experiments, different types of runs. Okay. So let me trying to see what the minimal example is. Okay, let's yeah. So we'll just follow the minimal example here. So we'll just install and the smallest script which will log things. Okay, that's all we'll do. So we can just pip install. So for that, we need to ensure that we are go back here. So we are in our virtual environment already. So that's great. So I don't have to do source activate the virtual environment. And yeah, so I just created a separate folder. I mean, we'll not need this yet, but let's just do the pip install first. Sorry. Right. Wow. So it has a lot of dependencies on pandas and many other things, but wow. So okay, it's taking some time. In the meantime, some reason internet is slow here. Wow, this is just a lot of installations. Okay. So we're not going to use a managed MLflow server. Let's yeah, let's skip those. The previous step was just saying if you want to have a server running that you want to save that data to a server. So we're not going to do that. Let's just save it to local subfolder. So let's just train a simple model. If you look at this, you can see that we are just creating a simple data set. I mean, in fact, we are just loading iris data set, which you might have used before. And then we are just creating a test train split. This is very standard pattern in scikit-learn. and there's some parameters here, and we are giving those parameters to the logic regression class to create an LR object, and then doing a fit, and then we are making a prediction on the test set. Okay, so currently this code is let's just see. Okay, they have separated the definition of these. Okay, let's see. I'm just trying to see with the MLflow code. We'll do that later. One of the challenges with these tools is they keep changing the APIs. So now they've introduced Gen AI component to there. So 1 year ago, probably it was not there. But anyway, so let's create a new file here. Okay, so this doesn't currently have, it does have this info signature, which is getting imported, but currently, so far, I mean, in terms of execution, it's just pandas, just scikit-learn steps here. Let's go back to the yeah. So okay. So those steps, we're just going to copy that information from the previous run and store it in the. So what we don't have is a tracking server. Let's see if it works by default by creating a local folder. So what it's doing is basically what the new steps is basically we already created this dictionary called params above. And so we just log params with the dictionary as an argument for that. Similarly, accuracy was computed earlier a few lines ago on the test data set. I'm just logging the metric over here. So as I said, the metric and the parameters are just, if you were doing an explicit for loop for in each epoch, pass to the data set, look at the validation loss, then you can call this log metric in that for loop. And so you'll have a time series so that you can have a plot you can observe, okay, instead of one number. And then, so the signature part is just for explicitly saving the model parameters, the learned parameters. So with that, let me clear this. Okay. Should have seen. I think I have a. It looks like I need to start a local server to show the last part. I was just going to show you the UI, which comes built in. So one of the advantages of this tool is not just the logging part, but also a simple UI. So let's run a So this is from that same page. We'll just start the server. Okay, so a server is just a place where when you run this training script, it will just save that information over there. So okay, so that's just continues to run in that tab. Let's go back here, and okay, with that we can. Sorry, which yeah. Config. Yeah, I'll just open it in the. I think it was 8080. Sorry, it's not correct. Yeah. So I mean, this is the last part, just to show that what did we save, right? Actually, feel like I did not run the. Yeah, actually we did, but I don't see the run logged. Back with the bash. Oh, I didn't save this. That's because there's a circle over there. Okay. And you'll see the information this time. It did show that okay, that particular experiment doesn't exist, so it created that experiment. And so previously in the tab you only saw default. Instead, now we have that experiment name, and it gave some information about what did it store and some version numbers and so on. So let's actually go back to that tab. Let me just refresh it. So you should be able to see the MLflow quick start experiment, within which you will have multiple runs that you can run. Sorry, that you can. I mean, every time you run it again and again, you will have one extra row here, and it also has a model that's already also versioned. I mean, the model that was generated from the scikit-learn execution. But if you click on this, you can actually see what was stored, right? So the parameters are exactly stored here. The same things which you saw in the dictionary in the code. Those choices of number of iterations and number of classes and which solver for this in this case was needed. The metric, which is the performance value for this. Generally, if there are a lot of numbers, then you can actually click on it and you'll see a plot. But in this quick start, there is no plot. And finally, artifacts. Don't think we saved. So we did save the model, but otherwise we did not. So model.pickle file, because the scikit-learn models are generally saved as pickle files. So we have the pickle file. But you can also have other artifacts. Artifacts just mean things which are not exactly just numbers or a list of numbers. Okay. So it could be a confusion matrix plot itself, for example. Okay, so these are all text files, but they're actually specialized to doing some other things that MLflow also is capable of, in addition to model serving. So I know in the first bucket, we saw Flask-based approaches to serve a model from the client-server interaction. MLflow also provides a way to serve these models that are stored, okay, that get versioned here. Okay, so the versioning part is just what I wanted to focus on. So if you run it multiple times, there'll be multiple versions with increasing numbers here, and whichever model you want to work with, you can actually it will let you know. Sorry, you can expose that model to the world and serve it. Okay, so the serving part I'm not going to focus on because we've spent a lot of time on it. Any questions about this? So this was just an example tool. We don't have to be wedded to MLflow, but giving a sense of how you version it. And for example, this tool does it by just adding an extra bunch of calls. Okay, this is very similar to logging calls or print functions that you would print statements you'd have. That's all that's happening. So it doesn't affect much of your code, just does an extra logging so that you can take care of logging and then curating your output model artifact so that it can be used for version control. Okay, no questions here or any questions? Okay, so what we'll do is we did 2 version control experiments. One is code, the second one is model. We look at one more tool just to kind of wrap up the trifecta here. We'll also try to version control data. Okay. Now, again, a disclaimer, these tools are not the only tools. We just see a couple of tools here, but the problem statement is the same. We need a way to snapshot our progress. Okay. So with that, not the last tool, but the last tool in this category is a tool called DVC. DVC, I guess it is named because I think it's called data version control. But it's basically a tool. There are many tools like this, and they all have different ways of thinking about what is exactly how to version control. But DVC is one which tries to follow the Git way of Git add, Git push, Git pull type of a workflow, so that it's not very alien to if you're already coming from version controlling your code, you can version control your data as well. Okay, so there are a lot of details. Many of these tools have evolved over time. I mean, when this first started, they were just focusing on one part, but they're now doing more. Again, for this tool, the one sentence summary is that it can let you tag your data so that you know which data goes with which snapshot of your code. So, for example, at some point in your snapshot, that snapshot corresponded to logistic regression, and then 2 snapshots later, that snapshot is using, let's say, random forest. But between those snapshots, the data set was also slightly different. Maybe the data set increased in size, maybe became double. So you can always roll back your code, but with that, you can also roll back your data as well in case you want to re-execute. Especially if you have the same random seed, you should be able to get the same answer as that number. Okay, so it's not just the numbers that are stored. You also can roll back and actually execute the same thing in a nice way. Okay, obviously you can do that by just remembering, okay, you're not touching the data throughout the whole process, but that's not. Many times what happens is a lot of data issues. Okay, so there are outlier numbers, especially tabular data, right? That's why you would typically look at slicing and dicing of columns to get a feel for like what are some missing values, outliers, incorrect data in incorrect fields. Those are things that you would do in data processing, data prep step. But there's also other types of errors which are a little bit harder to find, which is annotation errors. Okay, so for example, for images, you might, the annotator, the labeler who labeled the data might have incorrectly labeled it just because of fatigue or maybe just error, right? So because of those things, even your curated ML data set for ML training could also be evolving because of, you would want to fix these corrections. Okay, so and that's why we want to control data as well. There are many ways to do this. For example, you can literally have a table timestamp with if you are working with a database, right? So you can have literally timestamps so that every time the table allows, you can always make a copy with an appropriate timestamp metadata, also tagging along with it, right? But here we'll do it very similar to the way you do it with Git version control. Okay, so let's actually just do the getting started, which is. So what we need is actually let's install DVC. It's going to be very similar to MLflow. Pip install DVC is the command. Let's install it and then walk through. So they have their own scikit-learn example. So let's actually use them. So okay, before we do that, let's actually check what did we do. We created the MLflow example folder. So we have just one file MLflow example. Let me just actually git commit that. Git add. And then, oh, now we are in a different branch. Actually, I forgot. Different branch, which is fine. So today we'll commit both MLflow and the DVC example. We'll do the merge process at, after in a few minutes. So that way it works out. So because the other branch, we already kind of used it and merged back, so we don't want to use that branch anymore. We can delete that branch if we want. Also, the Copilot example branch. Anyway, a good practice, another is also to check which version of MLflow got installed, right? So there are multiple ways to check this, but 2.10.1 was installed. So it's actually good to create a requirements.txt file so that you can log which version actually works. I mean, this is like a minimal, we should be doing it more thoroughly, but for example, if we go to MLOps code examples and then MLflow example, all I'm saying is we can create a file. Let me just do. Okay, so this is just a way to say, okay, which version of the software is required for this example to run. It's actually DVC. I think we just installed it, or yeah, we installed DVC. So that was just pip install DVC. In fact, even for DVC, we should be checking what version it is. Let's do the again Python. Actually, DVC. I don't think this is like this. So let's actually. Three point four, 3.1. So actually, we can again do requirements. It's not, yeah, requirements.txt. Okay, so this was just bookkeeping. It's not really instructive. So let's actually do the example. So the way you do it is just like, so generally when you create a fresh Git repo, so you, which we did not see, by the way, I was working with an MLOps code examples. The first time you want to create a Git repo, the way you do it is Git init. It's like, should not have done that, but okay, Git init would be the command you would do to say, okay, this folder is now, we want to snapshot things. It's just local. Similarly on GitHub, when you click a new repo, it is a very easy step-by-step way to create a repository there. And it will also tell you how to clone that repository, and it'll create a folder for you. So all I'm saying is the initiation step is pretty straightforward. If you're not related to GitHub or any third-party vendor, you can just do Git init to kind of make your folder, start tracking things. And if you use a vendor like GitHub, you can just use the UI to start a Git project, Git repository. Okay. But actually, the command we wanted to run was okay. So we did install it. So we don't want to do anything more. So let's just go to getting started. So yeah, so here it actually worked out because we were supposed to create a Git repository first. So it said make directory example get started and Git init, which we already executed. So let's ignore that. And once you have a Git repository, now in addition to Git commands, all we're doing is let's actually close table, for example. So for example, if we do Git status, it says we are on branch master. Actually, we are already on Git. So let me actually remove that Git folder. Okay, so that's the hidden folder to kind of track your snapshots. Because I'm already in my code example. So if I say Git status, now it'll say, okay, we added a requirements.txt file, and DVC is not tracked because there's no file in there. Okay, there's no file, it's just an empty folder. So let me just add MLflow example and requirements and git commit. It's fine. Now we'll do DVC init. Okay, so that's because I need to go back to the top level folder and run DVC init. So the top level folder is my Git repository actually. So at that folder level, I want to run this DVC init. What it does is now creates. I don't know if you can see. Let me just move this 20 something. to outside. Um, so if you see the entire list of folders, including hidden folders, okay, hidden folders are where these things are tracked. Okay, I did not mention it last time with Git, but there is a folder called .git, which is where the snapshots of your code is. That's why the working directory is not paramount, sacred, or anything like that. You can just switch branches, and the working directory's files will change, but all that information is in the Git folder, in the .git folder. Okay. What we did now with the git init command is create a equivalent folder called .dvc. Okay, which is where your data version control related metadata is stored. Okay. And these git ignore and dvc ignore are just a way for the programs to know what files to ignore. Okay, for example, if you don't want to commit your secret keys, like an OpenAI, for example, if you want to write your own interface, right? OpenAI wants you to use a secret key. Okay, and that those keys you should typically not be committing to these types of repositories, because if in case you make it public, other somebody else can view it on GitHub or some other location and make use of your keys to exhaust your resources or whatnot. Okay, so ignore files are a way to ignore such files. So what we did so far, just dvc init. So there is going to be, I mean, from the Git's perspective, Git will see that there is actually a dvc .dvc folder that's created. See, we can do that right now. So .dvc folder, .dvc folder, which has its own git ignore, and then config and some dvc. Those are the three files, which are just metadata. Okay, there's just way to track now change in data. Okay, so we can do that commit, but we'll come back in a second. Let's just do data management. They also do model management. DVC now does not just data management, but model management. But we will kind of focus on. Okay, so what we'll do is first get some get some example data. So we're just going to call this function here. It's just going to copy some data. Okay, so it's not doing anything. And we'll do that in the DVC example folder. We're getting it's just a text file, XML file. It's just a bunch of, it's like a CSV file with a bunch of data points. Okay, so this was a folder that we created. In the folder, look at the data. There's a data.xml file. That's just a data set. Okay? We didn't do anything else. Requirements was something that we just wrote, right? When you wanted a DVC version. Okay, so now the way you track data set is very similar to how you track code. Okay, so if you want to track this data set, what you do is say, okay, I want to create the first version of this. Okay, whatever the current data set is, which might have errors, bugs, and whatnot. Let me use that. Let me just add it. Let me just go back here. Okay, actually, the folder doesn't matter. So actually, yeah, folder matters because it needs to have the right path. So let's add the data, right? So it says it added. Added just means the config file and the .dvc folders files have changed, basically. Okay, so we can just add these files, git add. So we have changes to be committed. Just some commit name with Git. So the committing is happening with Git. So we added the data, and then we can add. Actually, did we create this file? Did we add this? Okay. Yeah. So to track the changes with Git, we need to run this command. Um, so So adding is just, so what we did with DVC is just create an extra file called .dvc, which is there's the original data file called data.xml, and there's an extra file called .dvc that was created when we ran the dvc add command. And that extra file is what is tracking via Git. So Git doesn't track the data set itself, okay? But that would be crazy to have like a copy of the data every time you snapshot things, because data could be like not just MB, so it could be gigabytes in size. So what you actually track, what DVC helps you track is it kind of creates a metadata, some sort of like a, um, like a summary of this data, and that's stored in the .dvc file here, and that's what Git can track. So that Git doesn't have to have like huge, large files being tracked from version snapshot to snapshot, because otherwise it will be very infeasible, right? If you make 10 snapshots from 1 GB of a CSV file, then you'll have 10 GB of kind of files lying around. Okay, that's just not feasible. I mean, that's not an optimal way to do it. So even this you can this is the right data. Okay, so that's the I forgot to add these other ones, but it's okay. So we added some raw data. So now what you could do, there's more steps, but I think yeah. So there are more steps, which is like exactly very similar to Git. Git has a remote, which is the GitHub location. Similarly, data can be paired with like a remote location. So for example, here, we can have a remote location. Let's just create a remote location here. I'm just creating a simple local directory, but let's not worry about it. It's not a local directory. You can create a remote location anywhere else. So actually, we don't need this. So now DVC knows that there's a remote location where the data can be saved. There's a local location where the data can be saved, and it can sync those two. Just like Git can sync local code and remote code, DVC can also now start syncing. Okay, and there's nothing magical here. Syncing is just pull, push, and that's about it. Okay? So every time you update data somewhere, you just want to push it to the remote location. Also has the same version of the data that is there with you. That's all. Okay. So yeah, for example, if you just do DVC push, so actually we can just use this right-hand side to just look at what's happening in this folder, right? So there is a data folder when we downloaded the data. Remote folder is just this fake remote location. Currently it doesn't have anything, right? So it's an empty folder. So if you just do DVC push, now you'll see that in the remote folder, now there's a, its own way of defining like what the remote data is. It's not interpretable form, but it's like, it has this information, this data set, a copy of that data set over there. So I'll just show one last thing, which is if you actually DVC pull should not change anything because we already have the data. So yeah, it just compared what's the data that we have, and there's no difference, so it didn't really do anything. Let me just move data to, and if I pull, uh, use, oh, did not work. Uh, okay, I think the data was trying to simulate a fresh. Oh, okay, you need to actually not just remove that folder, but also remove something called a cache. And then you'll be able to see the recreation. So let me just do that and wrap this up. Maybe RM. So now it should just create that data directly for us. So that's why it's saying it's one file fetched and it's in that folder. Oh, it's not here. It's in a different location. Wow, I think I'm doing something. Oh, okay. It would have created the data not in the local location. That was just the downloading of the data. The data is going to be stored still in that cache location. Okay. So this is where we had deleted that folder before doing the pull operation. Now, if you look at the files, it's actually not stored in a interpretable format that we had, right? So it's let me just not go into this that directory. You're not supposed to go into that directory, so let me not get into that directory. But the steps are exactly that. So pulling and pushing is the way you synchronize data set. Okay, let me not get into too many details over there. Yeah, so we'll not edit the data and then pull push because it's exactly the same as get. But so any questions about this part? I don't want to uh, stretch it too long. Stretch it too long as well as not do something beyond the happy path that's written here. If there are no questions, let's take a break. So after the break, which is 10 minutes, after that, I can just wrap this DVC up for those who want to wrap up the remaining steps. But the remaining steps are just exactly pulling and pushing and just synchronizing two data sets. The intention for me was to also show scheduling and testing, but we'll try those softwares out, the example softwares in those categories out next time. Okay. So let's take a break for 10 minutes and we can resume back. And if you have any questions about what we saw today, definitely ask. And if you have questions about the projects, definitely let me know. Let's discuss. Yeah. Okay, let's take a break. Okay. Yeah, I mean, after the break, it's mostly a discussion, and there's not going to be much instructions. I just wanted to wrap up this part, which is so just I cleaned up the repository. I did a data hold and stuff like that right before the break. So what we're doing is basically just to recap the steps so that at least it's not too confusing for this version control. Is that first we got some data. It's just in a subfolder called data.x. It's in a subfolder called data. We got the data. We added the data. So this act of adding just creates an extra file called .dvc. It's just a text file. It just remembers what the data was, like some sort of a summary, like MD5 sum or some sort of signature of the data, so that we know that that's the data. Okay, and then basically that .dvc file is created, and you want to kind of just save it into your Git. So now we're back to Git, remembering that this was the data that we want to kind of snapshot now. So we're not directly saving the data in Git. We're just saving a kind of some sort of signature of the data in Git. Okay. After that, you can just delete that data if you want. But obviously deleting data if you don't have another copy is not good. So the way you would do it is you can push that data remote to some remote location. Like here, they're just showing it in a local directory that you can have a copy there. So that now DVC knows, okay, here's the remote location, and this is the data I'm tracking. And then you can always delete the data folder. And every time you do a git checkout, when you check out, then we know that there was supposed to be a data set associated with that snapshot. And so that data set is now fetched from this remote location. So what I mean by that is, for example, right now, we have a remote we're not going to track, but remote had that data set we just saved, right? Let's look at remote. Actually, let me just go to remote and remove this, whatever files there are, so that let me just add that remote. Okay. So what happened with that is just as yeah, we did not push. Right now, there's nothing in there. So push will just create a copy of this data set that you need over there. Okay. So now what we can do is, for example, right now we have this data folder. We can remove this data folder. RM. We remove the data folder. If you look at this, a lot of changes have happened. The data folder is no more there, right? So a lot of changes have happened, which is fine. So now you can make another snapshot and move on. But let's say you want to now come back to this Git version. So if you made changes and snapshotted, now they have new Git commits. But if you wanted to come back to this Git commit, so if you can just do Git checkout to a specific commit location. So for example, just to give you a sense, what is this commit? This is the commit ID, okay, of Git. The what we're tracking is the code, right? So I can say Git checkout. I can just give the commit ID. Okay, so okay, I think I made a mistake, but yeah, so should not have done the detached head. Yeah, so what happened is basically I've rolled back, and then because I rolled back, I got back this folder that we removed earlier. Okay, and then we can just do tvc pull to get back that file in that folder. So all I'm trying to say is that Git is making a copy of, keeping snapshots of your code. With the code, it also maintains the signature of your data. Okay, so every time let's say you Git checked out some previous copy, which is what I was trying to do. Any snapshot that you check out, if there's a corresponding data signature, that will also be populated, and then you can just call dvc pull to get the actual data corresponding to that signature. So for example, there's a signature corresponding to 1,000 rows of your data, and maybe in the next commit, you have a signature corresponding to 2,000 rows of your data. In some future period of time, if you go back to the previous commit, you'll get the signature for the 1,000 rows, and then you can do git pull to get the actual 1,000 rows instead of now maintaining 2,000 rows. So you can actually track both data and code together. That's the only innovation here. And why we are not putting data directly into Git is because Git is not the right tool for handling large volumes of data, like even megabytes or gigabytes of textual data, let's say CSV files or some things like that. It's not good to snapshot them. It's not a good practice to snapshot them with Git itself, because if you do that, then you don't need DVC, right? You can just literally say, okay, data, is part of that ML run or ML code that I currently have. You can always do that, but it's not considered best practice. So I just wanted to clarify that. Any questions about this part? I didn't want to confuse you more, but I just did a detached operation, which is not, which is kind of a little bit of a deviating from the standard path. But any questions about DVC? So okay, so just wrap up. We just wrapped up Git version control today. Looked at ML flow for model version control. We only ran once, but if you could run multiple times, you just see more rows in that ML flow UI. And lastly, data version control through one such tool, which kind of tries to mimic the Git way of pulling and pushing and keeping copies of data as a function of the commit. Okay? But there are many other ways, timestamping data, data warehouse, for example, and many approaches. It just depends on the organization which way you want to track all these three types of artifacts. Yeah, I think that's all I wanted to say.